Now, in this lecture, we will find out the value of angle theta. In the drawing, we have triangle ABC. Triangle ABC is an isosceles triangle, that is to say, side CA equals to side CB. You know that this angle ACB equals to 20 degrees in size. This angle NAB equals to 50 degrees, and this angle NBA equals to 60 degrees. Our mission is to find out the value of this angle NAB, that is equal to theta. So we'll focus on triangle ABC. So I'll copy triangle ABC again in a new page. This angle ACB equals to 20 degrees. Okay, this is triangle ABC that I copied from the original drawing. Angle ECB equals to 20 degrees inside. This gives us the equation that AC equals to CB. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two sides, of those two equal sides, we have those two angles that must be also equal to each other. So if one of the angles equals to theta, then the other angle will be also equal to theta. And we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, theta plus 20 degrees must be equal to 180 degrees. Theta plus theta is 2 theta plus 20 degrees equals to 180 degrees. We subtract 20 degrees from this equation, and we get that 2 theta equals to 180 degrees minus 20 degrees is 160 degrees. We divide this equation by 2, and finally we get that theta equals to 80 degrees. Theta equals to 80 degrees. So this angle in total it is equal to 80 degrees. So angle NAB equals to 50 degrees. In order to complete the size of this angle to 80 degrees, the missing angle must be equal to 30 degrees, of course. This angle also equals to 80 degrees in total, and this angle equals to 60 degrees. So the missing angle must be equal to 20 degrees in order to complete the size of this angle CBA to 80 degrees. This angle must be equal to 20 degrees. Okay. In the next step, we will focus on triangle NAB. So I'll copy triangle NAB in a new page. This angle equals to 80 degrees. This angle equals to 50 degrees. Actually, this is triangle NBA with a copied from the original drawing. We define the missing angle as theta, and the sum of the angles in this triangle must be equal to 180 degrees. So 50 degrees plus 80 degrees plus theta, in total all those three angles must be equal to 180 degrees. 50 plus 20 is 130, so we subtract 130 degrees from this equation, and finally we get that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. The missing angle here is equal to 50 degrees. As I write down in the original drawing, this missing angle equals to 50 degrees in its size. So in the same triangle NPA, those two angles are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. In front of this angle, we have side AB. In front of this angle, we have side NB. Therefore, in triangle NBA, we conclude that side AB equals to side NB. AB equals to NB. Okay. In the next step, we'll focus on triangle AMB. This triangle AMB, so I'll copy triangle AMB in a new page and we'll analyze this triangle AMB. This angle equals to 60 degrees. This angle equals to 50 plus 30 is 80 degrees. Actually, this is triangle AMB that I copied from the original drawing. This triangle AMB, the sum of the angles must be equal to 180 degrees, of course, so we define the missing angle as theta. So 80 degrees plus 60 degrees plus theta, in total they must be equal to 180 degrees. 80 degrees plus 60 degrees is 140 degrees, so we subtract 140 degrees from this equation, and we get that theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So the missing angle here, angle AMB equals to 40 degrees in its size. So you can write down the drawing, the original drawing, that the missing angle AMB equals to 40 degrees in its size. In the next step, from point B, we draw line segment BD in such a way that BD will be equal to BA. Okay? Yeah. line segment BD is constructed in such a way that BD equals to AB. Again, BD equals to AB according to our construction. So we know that BD equals to AD, and AB equals to ND. AB equals to NB. AB equals to NB. I repeat again, BD equals to AD. Those two sides are equal to each other according to our construction. So in triangle ADB, this triangle ADB, we have two sides that are equal to each other, so I'll copy triangle ADB again in a new page. So actually, this is triangle ADB that are coming from the original drawing. Angle DAB, this angle equals to 50 plus 30, that is 80 degrees. And again, DB equals to AB according to our construction. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles must be equal to each other. But this angle equals to 80 degrees, therefore this angle must be also equal to 80 degrees. So I found out actually that angle ADB equals to 80 degrees in its size. I write it down. This angle ADB equals to 80 degrees in its size. The sum of the angles in triangle ADB must be equal to 180 degrees. If we define the missing angle as theta, then we get that 80 degrees plus 80 degrees plus theta equals to 180 degrees. 80 degrees plus 80 degrees is 160 degrees, plus theta must be equal to 180 degrees. We'll subtract 160 degrees from this equation, and finally we get that theta equals to 180 degrees minus 160 degrees, it is 20 degrees. The missing angle here equals to 20 degrees in its size. That is to say, angle ABD equals to 60 degrees. So we write down in the original drawing that this angle A is actually angle ABD. This is angle ABD that is equal to 20 degrees. Angle ABD, this angle equals to 20 degrees in size. So angle MBA equals to 60 degrees. Angle ABD equals to 20 degrees, therefore the big angle minus the small angle will be equal to the missing angle DBM. Look it again. The big angle that is actually angle ABD. The big angle is angle ABD minus the small angle that is actually angle AB. The big angle is angle ABD and the big angle actually is angle ABM. Here this is the big angle ABM minus the small angle that is actually angle ABD. Must be equal to the missing angle that is actually angle DBM. This is the missing angle DBM. Repeat again. The big angle ABM minus the small angle ABD must be equal to the missing angle DBM. Angle ABM equals to 60 degrees minus angle ABD. Angle ABD equals to 20 degrees. 60 degrees minus 20 degrees is 40 degrees. So the missing angle here, angle DBM equals to 40 degrees in its size. Angle DBM equals to 40 degrees in its size. We'll focus on triangle DMB. So I'll copy triangle DMB in a new page and we'll analyze this triangle. Triangle DMB. This is triangle DMB. So actually, this is triangle DMB that I copied from the original drawing. Inside triangle DMB, we have two angles that are equal to each other, they are both equal to 40 degrees. Again, we have the rule that in front of equal angles in the triangle, there are equal sides. In front of this angle, we have side DM. In front of this angle, we have side DB. Therefore, according to the rule that I mentioned, side DM must be equal to side DB. DM equals to DB. So I write it down in the original drawing. That side DM equals to side DB. So actually DM equals to DB from one side, but we have already found out that all those two sides, that is sides in two lines here, they are equal to each other. Okay. And anyway, we know also that DB equals to NB. again, dB equals to NB. Okay. So in the next step, we'll copy, we'll join points D and N together by a straight line. And we'll focus on the right triangle D and B. So I will copy triangle D and B in a page and we'll analyze the triangle D and B. So actually, this is triangle T and B to the copy to the original drawing. Angle TBN equals to 60 degrees. Angle TBN equals to 40 degrees plus 20 degrees, that is 60 degrees. In addition, found out that dB equals to NB. dB equals to NB in triangle DNB. And again, we have the rule that in front of equal sides in the triangle there are equal angles. In front of this side we have this angle, in front of this side we have this angle. So those two angles must be equal to each other. If one angle equals to theta, then the other angle must be equal to theta also. We also know that the sum of the angles in triangle DNB equals to 180 degrees. That is to say, theta plus 60 degrees must be equal to 180 degrees. Theta plus theta is 2 theta plus 60 degrees equals to 180 degrees. We subtract 60 degrees from this equation and finally we get that 2 theta equals to 180 degrees minus 60 degrees, it is 120 degrees. We divide this equation by 2 and finally we get that angle theta equals to 180 degrees minus 180 degrees over 2 is 60 degrees. So this angle theta is equal to 60 degrees, this angle theta also equals to 60 degrees. So inside angle triangle DNB we have three angles that are all equal to 60 degrees. Therefore, triangle DNB is an equilateral triangle. Triangle DNB is an equilateral triangle. That is to say, all the sides of triangle DNB are equal to each other. dn equals to nb equals to db. So write it down in the original drawing. dn equals to nb equals to db. Okay. And we have already found out that dm equals to nb. Those two sides are equal to each other. dn equals to dm. You can see it also means for one side dn equals to nb equals to db, because those are the three sides of the equilateral triangle DNB. From the other side, we have already found out that dm equals to db. If db equals to bm, then we get that db equals to, right here, that db equals to bm, and here db dm equals to db, but dm equals to db from one side, but db also equals to dn, because it is equilateral triangle. db equals to dn, here. db equals to dn, so I can write here that db equals to dn, and so dm equals to dn. Again, dm equals to db from one side, dm equals to db, again, dm equals to db from one side, here, from here, okay. dm equals to db from one side, but from the other side, db equals to nb equals to dn. So you can write down that db also equals to dn. db equals to dn. And from this equation, we get that dm equals to dn. dm equals to dn. dm equals to dn. Okay. In the next step, we focus on this side at point D. At point D. First of all, the green triangle is equilateral triangle, that is to say this angle equals to 60 degrees, and this angle equals to 80 degrees. Again, this angle equals to 80 degrees, this angle equals to 60 degrees. So this is point D, this is a coordinate from the original drawing. This angle equals to 80 degrees, this angle equals to 60 degrees. In total, 80 plus 60 is 140. Therefore, the missing angle must be equal to 40 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. If we focus on this side of the straight line at point D, the sum of the angles must be equal to 180 degrees. So 80 degrees plus 60 degrees is 140 degrees. Therefore, the missing angle must be equal to 40 degrees. In order to complete the sum of the angles on this side of the straight line at point D to 180 degrees, the missing angle must be equal to 40 degrees. So here, this angle equals to 40 degrees. So I'll copy triangle DMN and refer to analyze this triangle. Triangle DMN. We found out that this angle MDN equals to 40 degrees. But we also found out that DM equals to DN. DM equals to DN. This angle MDN equals to 40 degrees. Again, we have the rule that in front of equal sides in the triangle there are equal angles. So DM equals to DN. So in front of those two equal sides there are equal angles. That is to say, those two angles that are located in front of equal sides must be also equal to each other. So if one of the angles is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DMN must be equal to 180 degrees. That is to say, theta plus 40 degrees must be equal to 180 degrees. Theta plus theta is 2 theta plus 40 degrees equals to 180 degrees. We subtract 40 degrees from this equation, and you get that 2 theta equals to 180 degrees minus 40 degrees is 140 degrees. So 2 theta equals to 140 degrees. We'll divide this equation by 2, and finally we get that theta equals to 70 degrees. So this angle theta equals to 70 degrees. This angle theta also equals to 70 degrees in size. So actually we found out that this angle DMN equals to 70 degrees. Angle DMB equals to 40 degrees. So the big angle that is 70 degrees minus the small angle that is 40 degrees is equal to the missing angle theta. So I write it down. The big angle is angle DMN, that is equal to 70 degrees in its size. The small angle is angle DMB, that is equal to 40 degrees in its size. So if we subtract the big angle minus the small angle, must be equal to the missing angle, angle theta. I'll repeat again. The big angle, that is angle DMN, that is equal to 70 degrees, minus the small angle, that is angle DMB, that is equal to 40 degrees in size, must be equal to the missing angle, angle theta, that is the angle that we are looking for. Angle theta also is equal to angle BMN. So 70 degrees minus 40 degrees, it is 30 degrees. So we actually found out that the missing angle, the angle that we are looking for, angle theta, that is angle BMN, equals to 30 degrees in its size. And this is the answer to the question. In the next step, I will summarize the lecture. In this lecture, we found out the value of this angle, angle theta, that is angle NMB. We have here triangle ABC is an associated triangle, that is to say AC equals to BC. This angle ACB equals to 20 degrees in size. This angle NAB equals to 50 degrees in size. And this angle DB, angle MBA equals to 60 degrees in size. Our mission is to find out the value of angle theta. So focus on the associated triangle ABC. In the associated triangle ABC, side AC equals to side BC. Those two sides are equal to each other. This angle equals to 20 degrees in size. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one of the angles is theta, then the other angle must be also equal to theta. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle ABC. So angle theta plus 20 degrees must be equal to 180 degrees. Theta plus theta is 2 theta plus 20 degrees equals to 180 degrees. We subtracted 20 degrees from this equation and found out finally that 2 theta equals to 180 degrees minus 20 degrees, it is 160 degrees. We divided this equation by 2 and finally we found out that angle theta equals to 80 degrees in its size. So those two angles, each of them equals to 80 degrees. This angle in total equals to 80 degrees, but we have this angle that is equal to 50 degrees, so the missing angle must be equal to 30 degrees in order to complete the size of angle CAB to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, this is also angle theta, and it is equal to 80 degrees. But this angle MBA equals to 60 degrees. Therefore, the missing angle must be equal to 20 degrees in order to complete this, the size of angle CBA to 80 degrees. The missing angle must be equal to 20 degrees. Okay, then we focused on triangle A and B. This triangle A and B. So I call it triangle A and B in a new page and we analyze it. This is triangle A and B. This is a copy from the original drawing. This is angle theta is equal to 80 degrees. This angle equals to 50 degrees. Here angle NAB equals to 50 degrees. So the missing angle is angle theta. We define the missing angle as angle theta. The sum of the angles in triangle NBA equals to 180 degrees. That is to say 50 degrees plus 80 degrees plus angle theta must be equal in total to 180 degrees. 50 degrees plus 80 degrees, it is 130 degrees, plus theta equals to 180 degrees. We subtracted 130 degrees from this equation, and finally we found out that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. So the missing angle here, angle A and B equals to 50 degrees in its size. This angle A and B equals to 50 degrees in its size. So in this triangle A and B, we have two angles that are equal to each other. And we have the rule that in front of equal angles in the triangle there are equal sides. That is to say, AB equals to NB. AB equals to NB. AB equals to NB. Write it down here. AB equals to NB. Okay. Side AB equal to side NB. Okay, then we focus on triangle A and B, this triangle, so I copy triangle A and B in an image and we analyze it. This is triangle A and B that I copied from the original drawing. Angle ABM equals to 60 degrees in size. Angle MAB equals to 80 degrees in size. We define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. So 80 degrees plus 60 degrees plus angle theta, in total the must be equal to 180 degrees. 80 degrees plus 60 degrees is 140 degrees. So we subtracted 140 degrees from this equation and finally found out that theta equals to 180 degrees minus 140 degrees. This 180 degrees minus 140 degrees, it is 40 degrees. So the missing angle A and B equals to 40 degrees in its size. The missing angle A and B equals to 40 degrees in its size. Then we focused on triangle. In the next step, from point B, we draw line segment DB in such a way, line segment BD in such a way that line segment BD will be equal to AB. So BD equals to AD, BD equals to AB according to our construction. BD equals to AB according to our construction. Then we focused on triangle DMB. So I copied this triangle DMB and then we analyzed it. But before that, we have in triangle DMB, first of all, in triangle ADB, we know that side DB equal to side AB according to our construction. So in this triangle ADB, we have two sides that are equal to each other. Again, in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So, but this angle is 80 degrees, so the missing angle must be also equal to 80 degrees. And again, in the same triangle ADB, the sum of the angles must be equal to 180 degrees. Which angles we have triangle ADB? We have this angle that is equal to 80 degrees. This angle also equals to 80 degrees. 80 degrees plus 80 degrees is 160 degrees. So the missing angle must be equal to 20 degrees in order to complete the sum of the angles in this triangle in the ADB to 180 degrees. The missing angle must be equal to 20 degrees. So here we have angle MBA equals to 60 degrees. So the big angle that is equal to 60 degrees minus the small angle that is angle DBA must be equal to the missing angle that is angle MBD. So 60 degrees minus 20 degrees, this is 40 degrees. Okay, so then I copy triangle DMB in the new page and we analyze this triangle DMB. We just right now found out that this angle MBD equals to 40 degrees, and we already found out that this angle DMB also equals to 40 degrees in its size. Again, we have the rule that in front of equal angles in the triangle there are equal sides. So those two sides that are located in front of equal angles must be equal to each other. That is to say, dm equals to db. dm equals to db. So here, side db equal to side dm. Then I focused on triangle. Actually, we join points D and N together by a straight line. By joining points D and N, we actually created here triangle D and B. So I copied the triangle D and B in the new page and we analyze it. This is triangle D and B that I copied from the original drawing. This angle NBD equals to angle ABD equals to 40 degrees plus 20 degrees, that is 60 degrees. And we found out that DB equals to NB, DB equals to NB, those two sides are equal to each other. Again, DB equals to NB. Again, we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is theta, then the other angle is also theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. That is to say, theta plus 60 degrees in triangle DNB must be equal to 180 degrees. Theta plus theta is 2, theta plus 60 degrees equals to 180 degrees. We subtracted 60 degrees from this equation and found out that 2 theta equals to 180 degrees from 60 degrees equals to 120 degrees. We divided this equation by 2 and finally found out that angle theta equals to 120 degrees over 2 is 60 degrees. So the missing again here, theta is equal to those two angles, each of them equals to theta, therefore triangle DNB is an isosceles triangle because all of its angles are equal to 60 degrees. From the fact that triangle DNB is an isosceles triangle, we conclude that all of its sides are equal to each other. That is to say, dn equals to nb equals to bd. dn equals to nb equals to bd. Here, dn equals to nb equals to dn equals to nb equals to bd. Okay. Then we have already found out that dm equals to db from one side, but from the other side, again, dm equals to db. dm equals to bd from one side, but from the other side, db equals to nb equals to dn. So db also equals to dn. Okay? db equals to dn. From one side, db equals to dm, and from the other side, db also equals to dn. Therefore, again, from one side, bd equals to dm here, and from the other side, db also equals to dn. Again, from one side db equals to dm, and from the other side db equals to dn. From this equation, we derive the dm equals to dn. dm equals to dn. Okay, dm equals to dn. Then we focus at point on this side of point D. This angle equals to 80 degrees in size. This angle is one of the three angles of an equilateral triangle D and B, therefore it is equal to 60 degrees. Okay, again, we focus on this side of the straight line at point, this straight line at point D. This angle equals to 80 degrees, this angle equals to 60 degrees. Therefore, the missing angle must be equal to 40 degrees in order to complete the sum of the angles on this side of this straight line at point D to 180 degrees. The missing angle must be equal to 40 degrees because 80 degrees plus 60 degrees plus 40 degrees is 180 degrees. So the missing angle here is 40 degrees. So this is the missing angle is equal to 40 degrees. Okay. So in triangle DMB, in triangle DMN, we have this angle that is equal to 40 degrees. And found out that dm equals to dn. Here, dm equals to dn. So I copy triangle DMN in a new page and analyze this triangle. We just right now found out that this angle DMN equals to 40 degrees. This angle DMN equals to 40 degrees, and we already found out that dm equals to dn. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And the sum of the angles in triangle DMN is 180 degrees. So theta plus 40 degrees must be equal to 180 degrees. Theta plus theta is 2 theta plus 40 degrees equals to 180 degrees. We subtract that, so 2 theta plus 40 degrees equals to 180 degrees. We subtracted 40 degrees from this equation, and finally we found out that 2 theta equals to 180 degrees minus 40 degrees, it has 140 degrees. We divided this equation by 2, and finally we found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So this angle theta equals to 70 degrees, and this angle theta equals to 70 degrees. So the big angle DMN equals to 70 degrees. This is the big angle DMN that is equal to 70 degrees. But this angle DMB equals to 40 degrees. So the big angle DMN minus the small angle DMB must be equal to the missing angle theta, that is the angle that we are looking for. Again, the big angle is angle DMN minus the small angle, that is angle DMB, must be equal to the missing angle BMN, that is angle theta, that is the angle that we are looking for. So the big angle equal to 70 degrees minus the small angle that is 40 degrees, it is 30 degrees. So we found out finally that the missing angle theta, that is the angle that we are looking for, angle theta is equal to BMN equals to 30 degrees in its size. Okay, thank you very much.